निर्माण नो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students. Today in this session we will be studying regarding chapter 1, number systems, the very first chapter of class 9 from NCERT textbook. The topic, the heading, the name of the chapter itself says that we are going to deal with different types of numbers. We might have gone through different type of numbers in our previous classes also. We'll be just recalling all those types of numbers. A system of numbers, number system, a system of numbers. That means step by step we might have gone through different types of numbers. The very first type of numbers that we might have gone through might have been the numbers that we were taught in our early childhood regarding counting purpose only. When we move into the class, in the morning, our class teacher comes. She takes our attendance. Roll number 1, present ma'am. Roll number 2, present ma'am. Roll number 3, present ma'am. 1, 2, 3, 4, 5, she goes on saying this. Finally, the whole class has given its attendance. Then there are digits that we see is telling in the class regarding roll numbers 1, 2, 3, 4. That means she is counting the number of students that are present today and the number of students that are absent today. Those numbers which are used for counting purpose in our mathematical language, we call them as natural numbers. So the very first thing from the early childhood that was naturally taught to us was natural numbers. Natural numbers. And what for they were used? They were used for counting purposes. So the definition can be written as numbers used for counting purpose. Numbers used for counting purpose. And what were the numbers? 1, 2, 3, 4 and so on till infinity, till we can reach at some point. That is what we call it as infinity, never-ending numbers that are used for counting 1, 2, 3, 4, 5, 6 and so on. Then again when we moved on in our early childhood, then we came across one more important digit. As when I used to play with my friends, they had some chocolates in their pockets and I didn't have any. So when they used to ask me, how many chocolates do you have? I said, no chocolates. No chocolates means what? That means the term zero was introduced to me at that time. Zero. There were no chocolates. If it could have been one, I could have put 1 chocolate or 2 chocolates. No chocolates means the digit zero, which was given by a great mathematician Aryabhatta. Now, moving on to our next step of early childhood, moving next to our number, we got the total number system when zero was introduced to me. And the total number system include zero and natural numbers. So that zero along with natural numbers. Now the whole system was ready for digits and we call it as whole numbers. So the second number that came or that we came to know was whole numbers. That is natural numbers along with zero. This divided by this. So natural numbers started from 1. And now the second number, that is whole number, it will start from 0. Along with all the natural numbers. So 1, 2, 3, 4, 5 and so on. So the whole numbers begins from 0. Then moving on further to our next classes, when we moved on to various classes, various types of numbers were introduced to us. Natural numbers, whole numbers. Then we were taught even numbers. That even numbers means those numbers divisible by 2 that were included in the natural numbers and whole numbers, that is multiples of 2, 4, 6, 8. So we do not write there. Then we came across odd numbers, that is those numbers which were not divisible by 2, that 2 were included in these two types of numbers as 1, 3, 5, 7, 9 and so on. Prime numbers, composite numbers, various types of numbers were introduced in our previous classes. The most important that these are the numbers that we came across. Then what about the negative parts that we have studied in our previous classes 7th and 8th? So those were termed as integers. Integers, that means all the natural numbers along with its negative numbers including 0. That means we have natural numbers 1, 2, 3, 4. The negatives are -1, -2, -3, -4 along with 0. So 0 was also included in that. So integers we can say natural numbers along with its negative numbers including 0. We will be including 0 also. So all natural numbers, they are negative numbers with 0 can be represented as, it might have been from infinity, -1, -2, -3, -4, -5, moves on till where? Till infinity. So from infinity, we can say this is -4, -3, -2, -1, 0 is also included, 1, 2, 3, 4, so on till infinity. That means all those numbers that lie between -infinity to +infinity in the form of counting purpose, that is -4, -3, -2, -1, 0, 1, 2, 3. Such numbers are termed as integers. Moving forward into our class 7 and 8. In class 8, we have been introduced with one important type of number. That is what we call it as rational numbers. Then, what are rational numbers? Before moving on to the particular definition, can I ask you a question? That are only these are the types of numbers that we were dealing with? No. We were also dealing with fractions. We were also dealing with decimals. So, regarding decimals, fractions, we had learned various chapters in our previous classes. Combining all those, the fractions, the decimals, natural numbers, whole numbers, integers, if we combine all together, then we will be getting a single type of number, what we call it as rational numbers. Rational numbers. This was introduced in class 8. So let us move on in some details in rational numbers. As I have told you that it includes all types of numbers, natural numbers, whole numbers, integers, decimals, fractions, everything. Then how can a rational number be defined taking all sorts of numbers in a single bunch? So let us define the rational number in such a way that all the numbers would be satisfied. So rational number is any number which can be expressed, or you can say written, whatever you want to say, you can say. Any number which can be expressed or written in P upon Q form. The number should be able, or we should be able to write them in P upon Q form, where P and Q, they both should be integers, and Q, that is the denominator part of P by Q form, should never be equals to 0. If Q becomes 0, the number cannot be defined. We haven't gone through any such type of numbers where the denominator is considered to be 0. So Q should never be equals to 0, and P and Q both should be integers, and we should be able to write in P upon Q form. All sorts of such numbers are considered to be rational numbers. As I have told you, that we have taken natural numbers, whole numbers, integers, decimals, fraction, everything under a single heading, that is rational numbers. That means these are all numbers, natural numbers, whole numbers, integers, decimals. We should be able to write all these numbers in the form of P by Q. If it is possible, then only we can say. So let us check. Are we able to write these numbers in P by Q form, satisfying P and Q to be integers and Q is not equal to 0? Suppose we say first natural number. Let us take any natural number, say 3. It's a natural number. This is also a whole number. This is also an integer. So let us see, are we able to write it in P upon Q form? How can we write this in P upon Q form if we say that this is a rational number? So this can be written in this way. All the single digit numbers has a divisor that is 1. That means each and every single digit number is divisible by 1. So we can write this one as 3 upon 1. Now this is in the form of P by Q. This is something upon something. So this upon this. So 3 upon 1. So we can say this 3 is represented as P and 1 is the Q as defined by our rational number definition. Then the conditions would also be satisfied. P and Q are integers. 3, yes, it is an integer. 1, yes, it is also an integer. That means P and Q both are integers. And another condition, again, Q should not be equal to 0. What is the value of Q here? Q is 1 and not 0. So the conditions are also satisfied. That means we can say that 3 is a rational number. Let us take a negative number. Say you can say minus 6. This is an integer number that we have taken. Can this be written in P upon Q form? Let us try out. As I told you, every integer has a divisor 1. We can write this one as minus 6 upon 1. That means it is in the form of P by Q, where minus 6 is P, 1 is Q, Q is equals to 1, which is not equals to 0. So we can say that minus 6 is also a rational number. Moving on to some decimal part of the story. Let us take a decimal part. No problem. Suppose we say this is 0 upon 0.4. This is a decimal number, as I have told. That all decimal numbers, fractions, both natural numbers are rational numbers. So consider a decimal number also. We have gone through a negative integer. We have gone through a positive integer. Let us move on to a decimal. So this can be expressed as 4 upon 10. If you simplify it, it becomes 2 upon 5. Now this is the form of P by Q as per our definition. 2 represents P, 5 represents Q. So this is the form of P by Q. 2 by 5, where the value of Q is 5, which is not equals to 0. So we can say 2 upon 5 is a rational number. That means minus 4 is also a rational number. Now we have taken positive numbers as an example. We have taken a negative number as an example. We have taken a decimal as a number. Now only thing that is left out is this one. Is 0 a rational number? Negative is done, positive is done, decimal is done. Now 0, a very typical. The value, nil value, null. We don't have anything, but that we don't have anything, and it is can be written as a rational number. That's 12. This is 0. Again, it is a digit, and as I have told you, every single digit or 2-digit numbers or 3-digit number is always divisible by 1. So this 0 can also be written as 0 upon 1. So this is 0 upon 1. This 0 represents our P as per the definition of the rational number. 1, this is represented by Q as per the definition of our rational number. 0 can be written in the form of 0 by 1. That means it is in the form of P by Q, where P equals to 0 is an integer, Q equals to 1 is also an integer. That means P and Q both are integers. The value of Q is 1, which is not equals to 0. So we can say that 0 is a rational number because it can be represented in P upon Q form. We have checked all the numbers, all types of numbers that we have gone through till class 8, whether they were rational numbers or not. Now, a relationship can also be developed between different types of numbers. If we go through the definitions, natural numbers are numbers used for counting 1, 2, 3, 4 are the natural numbers. Whole numbers are 0, 1, 2, 3 and so on. Integers and negatives, positive numbers and rounded 0 and rational numbers includes all this. Now can we say that all natural numbers are whole numbers? We will have to check. 1, 2, 3, 4. Yes, 1, 2, 3, 4 lies in the whole number. So we can say that all natural numbers are whole numbers. Is the vice versa true? Vice versa means, can we say that all the whole numbers are natural numbers? So we will check. 1, 2, 3, 4 is there. The 0 is missing in the natural numbers. So we cannot say that all the whole numbers are natural numbers. That is not possible. That means what we have learned, all natural numbers are whole numbers, but all the whole numbers are not natural numbers. Again, let us compare these natural numbers with integers also. Can we say all natural numbers are integers? Yes, we can say all the natural numbers are integers because all the natural numbers are present here as 1, 2, 3, 4. Then we cannot say that all integers are natural numbers because the integers include the negative numbers which are not included in the natural numbers. Similarly, all the whole numbers are integers because all the digits of the whole number are included in integers. So we can say that all whole numbers are integers, but all integers are not whole numbers because the negatives are not present in the whole numbers. Comparing all this with here also, as I have told you, that a rational number, you can say it's a combined form of all the numbers that we have studied in our previous classes. All the natural numbers are real numbers, rational numbers. That is very true. All the natural numbers are rational numbers because all natural numbers can be expressed in P upon Q form, where P and Q are integers and Q is not equals to 0. 1, 2, 3, 4. We have seen that 3 can be represented in P by Q form. We have taken the example. So we can say that all natural numbers are rational numbers. All whole numbers are also rational numbers. We have checked for 0 also and a digit for the whole number also. All the integers are rational numbers. We have checked. We have taken a negative integer, positive integer and 0. All could have been written in P by Q form. So we can say all integers are rational numbers. Then, if all natural numbers are rational numbers, all whole numbers are rational numbers, all integers are rational numbers, then can we relate in the vice versa form? Can we say all rational numbers are natural numbers? No. We cannot say all rational numbers are natural numbers. Example, we can take. Suppose we take a number 2 upon 3. This is a rational number satisfying the definition in the form of P by Q. P is an integer, Q is an integer, and Q is not equal to 0. So this is a rational number. But this is not a natural number. We are not getting any single digit or 2 digits or 3 digits number. We are getting in the form of a decimal number. And all decimals are not considered to be natural numbers. Similarly, we cannot say all rational numbers are whole numbers. In the same example, we don't have any decimal places. We cannot say that all rational numbers are integers also because integers also they are represented by the natural numbers with their negative numbers and 0 and no decimal numbers. What if we do not convert it into decimal form? Then also we can directly plot 3 upon 4 on number line. This is another method. The first method, as I was relating it with the decimals, that is why I converted it into decimals. But without converting it into decimals also, this can be represented. This is 3 by 4. The value is 0.75 that we know, and since numerator is smaller than the denominator, that means the value lies between 0 and 1. This value is less than 1 since it is positive. If it is less than 1 positive, that means the value lies between 0 and 1. So how do we represent it? So let us take the number line this way. Again, we have taken 0, 1, 2 and so on. And this value lies between 0 and 1. Now what we have to do is, we have to concentrate on the denominator part. What is the denominator there? 4. That means we will have to divide this part between 0 and 1 into 4 equal parts. How many parts? 4 equal parts, depending upon the denominator. If denominator is 4, 4 equal parts. If denominator is 5, 5 equal parts. If denominator is 6, 6 equal parts, and so on. So here the denominator is 4. So divide this distance, this part between 0 and 1 into 4 equal parts. 1, 2, 3 and 4. We have divided into 4 equal parts. As soon as we divide into 4 equal parts, then we will be seeing what is our numerator. The numerator is 3. So we will have to take the third part. So 1, 2 and 3. So this one is my 3 upon 4. Let me tell you once again. It's a bit. Suppose we are given with 3 upon 4, a fraction where numerator is less than the denominator. That means the value is less than 1. It's positive. So the value lies between 0 and 1. And we have to represent this 3 by 4 on the number line. The value lies between 0 and 1. So between 0 and 1, we will have to make 4 equal parts looking at the denominator. If denominator would have been 5, then 5 equal parts, 6, then 6 equal parts, 7, then 7 equal parts, and so on. Here, as per our question, there is 4 equal parts, so we have divided 0 and 1 into 4 equal parts, 1, 2, 3, and 4. After dividing into 4 equal parts, we move on to the numerator. Seeing the value of the numerator, we will have to locate that number of points. So here it was 3, the numerator was 3, so 1, 2, and 3. So the third point represented my value as 3 by 4. Now, let us move on to the methods of finding rational numbers between two rational numbers. Till now, we have seen what are rational numbers. Now, we will be finding rational numbers between the two given rational numbers. So, there are two methods of finding rational numbers between the given two rational numbers. We can find as much as rational numbers required between the two rational numbers. In short, we can say there are infinite number of rational numbers possible between two rational numbers. The methods here we can include. First method we can say is our own. There is no particular name for it. It's a simple method, but we can let us assign a name. That is what we call it as equalizing denominator method. Equalizing denominator method. This is the first simple method to get as much rational number as required by us, and the second one is mean method. This is mean method. Let us move on to both the methods one by one for a simple example. Let us take an example from your NCERT textbook itself that find 5 rational numbers between 1 and 2. We'll be moving on with this method first. That is what is equalizing denominator method. That means directly we would be getting as much number of rational numbers as required by us. We here require 5. So let's move on with 5 only presently, but we can get infinite number of rational numbers between 1 and 2 by equalizing denominator method. That's the name assigned for the method. There is not particular name that has been given in the textbook, but it very well clearly indicates that we have equalized our denominators. So let us the two numbers are 1 and 2. These are the two numbers that is given to us. Equalizing denominator, that means it should have some denominator, and we know the denominator is always 1. We have discussed the definition of the rational number, so that means this has a denominator 1. 1 is divisible by 1, 2 is also divisible by 1. Now the denominators are equal. After equalizing the denominator, we need to check is there any number lying between 1 and 2. There is no number lying between 1 and 2 if the denominator is What we do is, we can multiply any number what we want, to the numerator and denominator of both the numbers. Here also we have to multiply that number, the same number here, the same number here, the same number here. Why the same number? To keep the denominators same. So let us take any number, you can say 5, 8, 10, 20, 50, 100, whatever you want to take, you can take. For easy purpose, we always take multiples of 10 if you want, but if you want to take 7, 5, it's your choice. I'll be taking 10. So let us multiply it with 10 here. So this 10 should be multiplied here also. So this 10 should be multiplied here also, in order to keep the denominators equal, and that 10 should be multiplied here also. Now these numbers becomes 10 by 10, and here the number becomes 20 by 10. Now since the denominators are equal, now we will be looking for those numbers in the numerators that lie between 10 and 20. Yes, there are numbers that lie between 10 and 20. That is 11, 12, 13, 14, 15, 16, 17, 18 and 19. Till 19, 20 is not included. We are talking about between numbers. That means these two numbers are excluded there. So here the first number that we can get is 11. You have to take the denominator along with the numerator. So the first number that you are getting in between 10 by 10 and 20 by 10 is 11 by 10. The second number is 12 by 10. The third number is 13, sorry, this is 10. 13 by 10, then 14 by 10, then 15 by 10, then 16 by 10, then 17 by 10, 18. Since we are asked only 5 rational numbers, so we will be mentioning the 5 rational numbers only. And so we have got the 5 rational numbers as 11 by 10, 12 by 10, 13 by 10, 14 by 10, 15 by 10. These are the 5 rational numbers between 1 and 2. So it's a very simple method. Just by equalizing the denominator, we will be getting as much number as required between the two given rational numbers. Let us once again revise the example. We had to find 5 rational numbers between 1 and 2. We took 1 and 2 and the denominators were 1. Since the denominator was same, but there were no digits or no numbers that were between 1 and 2. So we used a multiplier that is of our choice, and that multiplier should be used everywhere in the numerator and the denominator, keeping the denominators to be same. So we took here 10. So as soon as we multiply 10, again the denominator remains same, 10 and 10. And then we were looking for those numbers in the numerator part that lie between 10 and 20, and that is 11, 12, 13, 14. So we took the numbers 11 by 10, 12 by 10, 13 by 10, 14 by 10, 15 by 10. You could have taken 16 by 7, then 17 by 10, 18 by 10, 19 by 10. As much as it was asked in the question, we were asked 5. So out of those 9, we can take any 5. So we took the first 5 numbers to be the 5 rational numbers between 1 and 2. Second method, mean method. Mean method means, what is mean? Mean means it is the average. Since we are talking about only 2 numbers, so it is the average of 2 numbers. Suppose the 2 numbers are A and B, then the mean will be, the average means mean is equals to A plus B by 2. In general, the formula for mean is the sum of the numbers by number of numbers. Sum of the numbers by number of numbers. Here the number of numbers were 2, that is why the sum of the 2 numbers by number of numbers, that is 2. Mean is given by A plus B by 2. Using this formula, we can also find as much as rational numbers required between A and B. Let us move on to the same example that we have done for equalizing denominator, so it would be easy for us to understand. Here we have to find 5 rational numbers between 1 and 2. So the first rational number that we will be finding between 1 and 2 is given by, we will take A is equals to 1. Suppose we are given the 2 numbers, so we can take A is equals to 1 and B is equals to 2. So the first number, say M1, is A plus B by 2. So this is 1 plus 2 by 2, and this is 3 by So this is the first rational number that we have got between 1 and 2 using the mean method, using the formula for the mean. For the next, you can change every time the value of either A or B. In the first case, we had A is equals to 1 and B is equals to 2. For the second case, you can take suppose A is equals to 1, we keep as it is, and we can take B is equals to 3 by 2. So you can take B is equals to 3 by 2. If you take B is equals to 2 once again, you will get the same number. It will be repeated. So we have to change every time either the value of 1 or the value of B, A or B. So here this can be written as 1 plus 3 by 2 whole divided by 2. This is A plus B by 2. The numerator part, if you solve it by taking LCM, this is 2, 2 ones are 2 plus 3, the whole is divided by 2, so you get 5 by 4. This is the second rational number that we have obtained between 1 and 2. For the third case, if we take A is equals to 1, we have fixed the value of A. You can fix the value of B also. If you don't want to fix it, then also it's possible. You can take this one to be A and this one to be B. That is as your wish. For easy remembering, we fix one of the values, the original value is A or B. Here A is equals to 1, and now we will be taking B is equals to 5 by 4. Then we will be getting our third number. This is 1 plus 5 by 4 divided by 2. Again, you solve the numerator by taking LCM. So your LCM is 4. This is 4 plus 5 whole divided by 2, and you get this one as 9 by 8. This 4 comes to the denominator part. So you have got your third rational number between 1 and 2. Then again for the next one, if A is equals to 1, B is equals to 9 by 8 you have taken. Then the fourth can also be taken again by the formula A plus B by 2. So this is 1 plus 9 by 8 whole divided by 2. Solving the numerator by taking LCM, the LCM would be 8. Then this will be 8 plus 9 whole divided by 2. So this is 17 by 16. This is the fourth rational number we have got. The first one was 3 by 2. The second was 5 by 4. The third was 9 by 8. And the fourth that we have got is 17 by 16. Moving on to the last, because we had to find 5 only. So fifth one, let us fix A again as 1, and now B will change to be 17 by 16. And if you find the fifth rational number by the formula A plus B by 2, this is 1 plus 17 by 16 whole divided by 2. Again solve the numerator by taking LCM. Now LCM is 16. This is 16 plus 17 whole divided by 2, and solving you get 33 by 32. This is the fifth rational number between 1 and 2. And continuing this way, you can get as much as rational number you require using mean method. For our consideration, between 1 and 2, we have got 3 by 2, 5 by 4, 9 by 8, 17 by 16. And 23 by 22 as the 5 rational numbers between 1 and 2. Now, solution to the exercise 1.1 from NCERT textbook class 9 mathematics. The first question goes this way. Is 0 a rational number? Can you write it in the form P by Q, where P and Q are integers and Q is not equal to 0? Is 0 a rational number? We had discussed in our introduction part that 0 is a rational number, and we have expressed 0 in the form of P by Q as 0 by 1 if you remember. So we just need to write here the solution, and yes, 0 is a rational number. 0 is a rational number, and I have told you earlier also that all the numbers that we have gone through till now, natural numbers, whole numbers, integers, all are rational numbers. 0 being a whole number is also a rational number. I have told you that all the whole numbers are rational numbers. But here we have to mention it as per the question. Yes, 0 is a rational number. Can it be expressed in P by Q form? Yes, it can be expressed in the. Yes, it can be expressed. it can be expressed in P upon Q form. How it can be expressed? 0 upon 1 you can write. You can also write 0 upon 2. You can also write 0 upon 3. All the values are 0. 0 upon 1 is 0. 0 upon 2 is 0. 0 upon 3 is 0. 0 upon anything is 0. So this can be expressed in the form of P and Q, where P and Q are integers. Here 0 is an integer, 1 is also an integer. The value of Q is 1, which is not equal to 0. See, remember once again, P can take any value as an integer. It can take all negative numbers, it can take all positive numbers, it can also take 0. But there is an exception as per the condition of rational numbers, that Q can also take any integer value, but it should not be equals to 0. That 0 is possible for P only and not for Q. So here, this Q, this denominator can never be 0. So yes, it can be expressed in P upon Q form as 0 by 1, 0 by 2, 0 by 3, and so on, where P and Q are integers. If you can check it, where P and Q are integers, with the condition that Q is not equal to 0. Thus, we get 0 is a rational number, it can be expressed in P upon Q form, and P and Q are integers, and Q is not equal to 0. Moving on to question number 2. Find 6 rational numbers between 3 and 4. This we have done in the example also. We have found 5 rational numbers between 1 and 2 in the examples. It is the same way. Out of the 2 methods that we have discussed, equalizer, denominator method, and mean method, there is no specific there is no specific method that has been stated to be followed. So we can use any method we want. We will be moving with the easy method only, that is equalizing denominator. We are given with the numbers 3 and 4. This can be written in P upon Q form as 3 upon 1 and 4 upon 1. The denominators are same, and there is no such number lying between 3 and 4. So we will have to use a multiplier. As I have told you that you can use any number as a multiplier, but I prefer 10 for easy calculation. So we can use that multiplier 10, that is multiplied to the numerator and denominator of both the numbers, and finally we obtain those numbers as 30 by 10 and 40 by 10. These are the 2 numbers that we have now obtained, a different form of 3 and 4. Now since the denominators are equal, then we will be looking on to those numbers that lie between their numerators, that is between 30 and 40. Yes, we do have numbers. What are the numbers that we have? 31 by 10. We will have to consider the denominator with it. 32 by 10, 33 by 10, 34 by 10, 35 by 10, 36 by 10. We can take 37 by 10, 38 by 10, and so on. But we are asked only 6 rational numbers. So these are the 6 rational numbers. So these are the 6 rational numbers between 3 and 4. Between 3 and 4. So this is now the next question. Question number 3. Find 5 rational numbers between 3 by 5 and 4 by 5. Previously, they were simple natural numbers, 3 and 4, or you can say they were simple integers. Now we have fractions given, and these 2 fractions are also 2 rational numbers, as they are expressed in P upon Q form, and Q is not equal to 0. Now we need to find 5 rational numbers between these 2 rational numbers. The method is same. This is 3 by 5 and 4 by 5. The denominators are same, but there is no such number lying between 3 and 4. So we will have to use a multiplier. And the multiplier that we will use was 10. Multiplying that 10 to both the numerators and denominators of both the rational numbers. This now becomes 30 by 50, and this becomes 40 by 50. Now again the denominators are same, so there are numbers lying between 30 and 40, and those numbers are 31, along with the numerator, that is 31 by 50, 32 by 50, 33 by 50, 34 by 50, 35 by 50, 36 by 50. There are more, 37 by 50, 38 by 50, 39 by 50, but we are only interested in 5 rational numbers. Only 5. We have taken 6. So these are the 5 rational numbers. These are the 5 rational numbers between 3 by 5 and 4 by 5. And question number 4. The question number 4 is a true or false question that you can do it by yourself, as we have discussed in our introduction part also.